Good afternoon, everyone. From today onwards, we will be taking some closer looks on the topics in object-oriented programming. So today's topic is classes and objects. Now, what is a class and what is an object that we have already known? I have taught you in the earlier classes. And today we'll be looking for what is a class and what is an object, how to define that with the Java syntax. And we'll also be looking a closer look on how it works. So you already know about what it does. Now we'll be looking for how it works. So if I design a class in Java, so for example, class student, now I can take string for name. I can take integer type for roll number. I can also take integer type for your, let's say, age. Sorry, age. So if you look closer, like how a class is defined, so a class is a new data type. Okay. So here in my case, in our case, it is stud, like student or stud. So this is my data type right now. So I have created a new data type where I'm storing name as string type, roll numbers as integer type, and also age as my integer type. So it is holding two different data types into a single class. Okay? So class is basically a new data type. Okay? So now here we are just designing like what it does. Okay? So these are called attributes. These are called attributes. So if you remember the object modeling diagram that I taught in the last class, that is object modeling, where maybe you have a box like this one. Here all the attributes you have, and also we have some methods or operations. And things like these methods are the functions and these attributes as the data. For example, the method can be f of x, and this x represents, so this x represents these attributes, and this f of x is basically this method. So here the string, the integer type, this integer type, the name, role, age, these are my attributes. So we are just designing a template, a blueprint. Now if you ask me, this whether it has allocated a memory in our system or not, so the answer will be no, because we are just in the design phase, right? We have not allocated any kind of memory. So how to allocate memory? So to allocate the memory, we need to create an object. So a class doesn't have a physical value, whereas an object does have a physical value. Okay. So in my case, I'll just write stud, maybe uh, AB equal to new stud. Now we have to look closer onto this part. There are four parts that we can divide this line. One is this stud, this AB, then we have new, then again we have stud, and we also have some parentheses. So here this stud represents the class, and this AB is, for example, let's take it as a variable. So if I just divide these two lines, if I write stud AB, okay, and then maybe I am writing AB equal to new stud. So both are these are same. Why same? Because here we are just giving a reference. We are just giving a reference. We are saying that the AB is a stud type. Why stud type? Because here, as you can see, the stud is my class. Also, it is a new data type for my use case. Now, if I say the AB maybe as a variable, just take it as a variable right now. AB is a stud type. So we are just giving a reference that AB is a stud type. So it's a reference to an object. Now again you can ask, sir, whether the compiler will allocate the memory or not here. So the answer is no. Still it's a reference. We are not allocating any kind of memory here. Now we are saying that AB equal to new stud. Now we are assigning something inside the AB. Okay. Now what it is assigning? It is assigning the stud class. It is assigning the attributes of the stud class. Now you also have some parentheses here. Now whenever you have the parenthesis, it becomes a constructor. So in the upcoming classes, I'll be explaining about what a constructor is. Okay. So for this one, we have a constructor. Now by default, Java will allocate a constructor here. So up to this is your class name, and after that, if I add the parenthesis, it becomes a constructor. Now again, you can ask, sir, do we have a physical memory right now? Yes, we do have. So in this line, it is allocating some memory to the AB. So right now I can use AB dot name. So I can use AB. This is my new object. This is my new object. So AB. So this is the dot operator, and we are just accessing the attributes. You can also write AB dot role, AB dot age. Now please remember that in Java it is dot. This dot represents a separator, but as the dot is widely spread, is known to all of us, so we are just referring this as a dot operator. But in Java, it is a separator. AB dot name. That is a, like we are telling it as a dot operator, but in Java it is a separator. So this is how we can create an object and from the class. Now if I need to create another object, so there will be two options. One is I can just create another stud, maybe cd equal to new stud. So this is the same method that I taught you in this line. Again, I can also use stud cd equal to ab. Now this AB and this AB are same. So we are referring this CD as the new object, which is referring to the AB. So if I just draw like this one, suppose I have a class. Now I have an object that is AB. It is referring to the class. Now I have another object that is CD. This object, there are two options. It can also go to the class, but I am referring this CD to AB. So it will work because the AB is a reference to the class itself. Now my question is, if I delete if I delete this AB, whether the CD will also refer to the classes or not. So my question is, suppose I have this AB to class as a reference. Now I delete the reference from AB to the class, but the CD is still referring to the AB, right? So in the memory, suppose I have AB, I have CD, and this is my stud. So it has maybe lots of attributes. For example, name, age, roll number. You know? So my question was, maybe AB is linking here and CD was linking there to the AB. If I delete AB, will it work or not? In the memory allocation part, if I point AB to the class and if I point CD to the AB, basically it is pointing to the same class. So then also the CD will also work. Now a small introduction about method. Let us just understand the syntax of a method first. Now what is a method? Again, think like a function, like we have type, then we have a method name, and here we have some parameters, maybe parameter list. Okay. Now here, as I write type, now what data type it can be? It can be integer, it can be string, it can be double, it can be boolean also. Also, it can be a class type. It can also be a class type. So we can pass one class to the method. Okay. So method name can be anything. Now, what about the parameter list? So by default, if we wish, we will not pass anything. So it will just look like the parenthesis. But it is possible to pass the parameter like A, B, C, something like that. So just like the function, we can also pass the parameters here. Now it will assign the values in the runtime. So whenever we call the method, then only the A, the B, the variables A, B, C will get the values uh, from the compiler. Now many questions are arising that whether Java is a compiler or interpreter. So I have asked you this question in the last class, in the first class also. So there is a confusion. So let me just clear the confusion today. So it has an extension that is file.java. Now there is a compiler that is maybe Java C, Java compiler. So it is taking this .java file and it is converting this .java file into .class file, file.class. Now everyone says this is the bytecode. This is the bytecode. Also, many researchers also saying that this is a uniform code. Like why so? So in the file.class, think like it is a set of instructions. Okay. So in file.java, you have a Java code. All the codes you have write like this. Now the Java compiler is taking this file.java and it is converting into a file.class. And remember that the file name and the class name should be same. Otherwise, you'll be getting some error. So the file.java will create a file.class. Now, this file.class is basically the bytecode. The bytecode, think like suppose I have an input here and I have an output here. Now I have some gap to pass. Okay. Now this thing is basically the bytecode. Now, so it is an intermediate level. So this is the file.class file. Now we cannot easily see this file because it is like in the bytecode you cannot understand everything. This is a set of instructions for the machines, right? Like how to get the output then. there comes a machine that is called JVM, Java Virtual Machine. Well, this is not a physical machine. This is the Java Virtual Machines. Think like an interpreter that interpret each and every line present in the file class into your desired output. Okay. So if I ask you again, Java is a compiler or interpreter? So Java is both. Now, while converting this .java file to .class file, it is a compiler because it's compile each and everything, right? All the files. Now, after compilation, we need to interpret it into our system. So again, it works like a interpreter. So Java is a both, but it's a compiler first, then the interpreter. So in Python, we also have a Python virtual machines that work like the same way. So with this file.class file, remember this thing is totally independent. Okay? Why? Because I can share this file.class file to all of you, and if you have a Java system installed, the Java JVM or the JDK, whatever you have, you will be able to execute this file.class and you'll be getting the output. Now, for a real life example, if I ask you, like maybe you are using Windows operating system, whether Windows is giving you the code or the application. It is not giving any code, it is giving you a application, a file that the computer is running and you are getting some output, you are getting some applications. So thing like that, it is also in the same way, it is like we are giving the .class file and you are executing the .class file, you are generating the output. So that's all for today's class, and in the next class we'll be discussing more on the method part. Thank you.